when you have the opening of a replication area, you're going to have two replication forks. We have one here on the left and we have another one on the right. You have two template DNA strands, as we've discussed before. That is this one on the bottom, which is the black one labeled in like brownish color, 5' to 3', and then the top one, which has the orange labels, it's 3' to 5'. Notice again, the ends are opposite in the template DNA, in the two strands. Now, in the fork on the left, we have one DNA polymerase represented by this light green arrow and one DNA polymerase represented by this dark green arrow. Both the polymerases on the strand that they're synthesizing add at the 3' end. So we see that this polymerase is at the 3' end here. This dark green polymerase is also at the 3' end. But if you're looking at the big picture, then these polymerases are moving in opposite directions. And the one at the top, the dark green polymerase, is creating the complement to the lagging strand, or this is the lagging strand. And you can see that is because it can synthesize for a little bit longer. It could go all the way to this other new piece of DNA here. So it could synthesize all the way to here. Then it has to stop. And then I really should have drawn the restarts arrow from here all the way back to here, because then it's going to have to, again, restart, have the primase come in, lay down a primer, and it's going to move from left to right again, making a new fragment that will connect to this fragment that it's already made. Now, if we go to the opposite side of the replication bubble to this other replication fork, now this DNA polymerase here, which is a lighter blue color, this is making the lagging, or sorry, this is not making the lagging strand, this is making the leading strand. Even though on the same template DNA, for the other replication fork, we had the lagging strand. That's because this replication fork is opening in the opposite direction. It's moving farther to the right, whereas the first one we discussed was moving farther to the left. And that allows this polymerase to add on the 3' end and to move towards the replication fork opening, whereas the bottom polymerase here is now making the lagging strand. It can also only add on until it gets up to this new DNA, which was laid by this other polymerase. Then it has to go back, and really this arrow should be farther back here. It's not going to go right back to the place where it started. So this polymerase will go back over here perhaps, and then it's going to move in this direction. And then it'll start over even further to the right. So hopefully that's helpful.